Hello folks, this is Mr. Ege, and on this activity in this video I'm going to demonstrate how to create AutoCAD turbine blade design, and I also have written a number of instructions for this, and you can find it on the Schoology, and for the numbers that you like to take a look at it as a reference. But this particular activity, okay, will be about the turbine blade. And what is special about the turbine blade is that this is increasing the pressure of the turbine, and the water is coming at 90-degree angle from the input axis, and you can squirt the water a few times stronger, okay, from the outlet direction. So it's a 90-degree angle, inlet and outlet axis will make, and it's a turbine blade is going to rotate either because of the water pressure, 50 psi at the inlet, and it's going to just simply multiply the water pressure at the outlet, like 5-10 times. If you happen to make the turbine blade to operate, run by electricity or combustion engine, perhaps the outlet pressure will reach to thousands of pounds per square inch, maybe 10,000 pounds, maybe even higher, 50,000 pounds, who knows? That particular application is totally depending on designing engineers, okay? So please start AutoCAD, and right now I have AutoCAD in front of me, and I simply went to the workspace switching. I selected 3D modeling workspace currently. So that's what you're looking at. My screen is maybe a little bit different than yours. So I suggest you to go to workspace switching on the lower right-hand corner and select the 3D modeling switch so that you can get to see your user coordinate system XYZ reference point in front of me the way I see it. Okay? All right. So first things are first, we're going to create a circle command. And circle, C for circle. So I'm just typing C for circle, and it's asking me the starting point. Certainly, starting point is 0, 0, XY coordinates, enter. Okay? Now it's asking me the radius. Okay, I want to enter diameter of 5 inches, so I'm typing D for diameter, and then enter 5. Okay, and I'm going to zoom in so that now this can be extruded about, and I need a smaller circle as well. So this is only so enter again. Circle command comes back. 0, type 0, 0 starting point, and then this time the smaller circle will be a diameter of D, enter 1 inch. So I'm typing 1 for the diameter, enter. Okay. The big circle, large circle, is going to be extruded minus 0.25, quarter of an inch. So I'm going to use the extrude command. If I go move your cursor, and on the top left-hand corner from the ribbon, I select solid, okay? And I'm looking for the extrude command here. Solid extrusion, click on the extrude command and select the big circle, large circle, enter. It's going to be minus. So it's just type simply minus 0.25 minus 0.25 will be, okay, will work. Enter again, extrude command will come back. Then you select the smaller circle, enter, move your cursor a little bit higher so that you can see extrusion. And this is going to go 3 inches up, so type simply 3, enter. Okay. So far, so good. And what else do I want to do? I want to draw a vertical line from the same point. Okay. And at about exactly the same size. So I'm going to just simply click on the line command And the starting line, point of the line is going to be 0, 0, enter, okay? And it's asking me the first point, and I'm just typing 0, 0, enter, okay? And this computer has a tendency to select the second point on XY plane. So it's even capable of picking any point in the 3D world if you specify the Z. It has a tendency to pick any point on XY plane by the click of a left mouse button. But I want to pick a point, okay, on the top. For that to happen and trim each up, I'm going to type 0, 0, 3. So instead of Z coordinate, I'm entering 3. Enter. Okay. So the line is being created, but you don't see it right now. And I'm kind of concerned that I'm not seeing it either. So what do? I'm going to change my shade mode so that I can see the lines. Wire to wireframe. I'm going to change the shade mode. So I'm typing shade mode, literally a lot of word, and go to wireframe. I'm choosing the wireframe so that I can see the line. I just created this line. Okay, good. And one of the things I like to do on this line is I want to divide it. I want to divide it into 5 spaces, by the way. And divide command will suffice, will do this for me. So type divide, okay, D-I-V-I-D, basically spell it right, otherwise computer doesn't make guesses for you or spell check it for you, correct command. If it's the command, you have to spell it correctly, not like that, it's serious. More serious than any other program. So enter. And computer says now, AutoCAD tells me now, select the object to divide. Yeah, I move my cursor over and left mouse button and click on the line that I just created. Okay. Now, I am prompted for enter the number of segments. I'm typing 5 because I want 5 segments. This line to be divided into 5 segments. And enter. 5, I type 5, enter. Now, it is not talking about literally dividing the line. It is talking about putting a mark on the line without actually cutting the line. So when I clicked 5 and enter, it did not cut the line or something, anything like that. It just simply put some invisible lines. That's the thing about the AutoCAD you may not be so crazy about, literally, because it does things and on its own, unless you really know what is happening, it becomes a mystery to you until you find out. So what it did is put some mysterious points on the line so that line is divided literally into 5 equal spaces, but not literally, but by just mysterious marks. Okay. And I'm not going to waste my time too much for the simple activity, but what I'm going to say is there is going to be way to mark those points of division. If you move your cursor over lower right-hand corner, go to the object synapse, you will see a number of object synapses are on. One of them is called node. Make sure that node is selected. Node is one of those mysterious points by AutoCAD to denote the division of the line to 5. So it is checked. What that means is your cursor will see it. You're not going to see it by your own eyes. It was too much for AutoCAD, but it's not too much for you. So for your cursor to see it. So node is checked, meaning that I'm capable of now, I'm drawing lines at those intersections. So I'm going to go to line command, line enter, okay? And I'm going to pick the top point of the line that I just created, move my cursor, and cursor immediately sees that line at the end of the, and then I'm going to type, I'm going to make sure that I did it right. Line command, move cursor, click. Okay, very good. Okay, now I'm going to type a ½ inch to the right in either X or Y direction. Y direction is better. So, and here is the way to do this in AutoCAD. And add symbol, you need add symbol here because you already picked the first line. Because you already picked the first line, second line should be in relation to first. So relative coordinates entry has to be entered. So type add and type 0, comma. How long is it supposed to be? 0.5, right? So 0.5, okay, comma 0. So basically, in Y direction, it's supposed to be an enter key. Ta-da! All right, first line has been drawn. Okay, this is good news. Now we need to copy this line. So CP for copy. I select this line. I pick the endpoint of the line. Now I'm moving down to find node point. This is the node point indication, ladies and gentlemen. Take a look at it. This is the node point. Okay. Every time I see, like, I click on the left mouse button. Node, when it sees the node, I click the left mouse button. I press the thumb wheel, just to make sure that as soon as it sees the node point, it shows me in the green mark. This is the node point. Division line, that's the division line. I'm going to put one at the bottom. And there is supposed to be a node point somewhere around here. Okay, there it is. That's the difficult one. This was difficult, coinciding with the intersection of the other line. And enter key. Now, this is the point you want to save your work. So, home, you have AutoCAD, save as, and save as to your OneDrive. I'm going to save it somewhere I am allowed to save. My drive. Google My Drive, yeah. Okay, and save. Okay. Now, next thing to do, I'm going to select each line and lengthen it. Lengthen, believe it or not. Hard to say it, but lengthen literally extends the line. Okay. So I'm going to type lengthen, L-E-N-T-H-G-E-N, enter. Oh, I just spelled it correctly. How cool is that? L-E-N-G-H-T-E-N, lengthen, and now it says select the object. Okay. So the first object, the top line, 150. Okay, so I'm going to select this top line. Perhaps we should keep that 150. The second line from the top, I'm going to use this one. Okay, and it says, gives a bunch of options, select percent and type 150, enter. So 150%, 50%, 150%, select the line, enter. I'm going to use this one, lengthen command, one more time. And select the line, enter. Now, enter again. This time computer is asking me again. And percent, enter percent. Now this time I'm entering 200%. Enter. Select the second line, enter. Okay. And then enter again, twice. One for closing and then enter again, third time. For the percent option, 250. And okay, enter. Select the line. Good. And enter again, command ends. Enter again, command comes back. Enter again, percent has been selected. This time we're entering 300. Enter and moving to center line. Okay. Enter again, command ends. Enter again, command comes back. Enter again, percent comes back. And 350% type. Enter. Select the line. And finally, quite a few enters. Your finger may get tired. Okay, enter, enter, percent, enter again. This time we're entering 400. Enter, and then select the last line. Click on it. Ta-da! Enter again. You're done. And save your work, of course. It's not complete yet. However, we're getting there. All right. So far so good. One of the important thing is once this is created for the turbine blade, we're trying to create one turbine blade. After that, we're going to multiple copies. But there's a process, okay? It's a spiraling price process. So those lines, except the first one, needs to be rotated, 30-degree angle. And the 3D rotate command is a good command, but I suggest only rotate command. So 3D rotate or rotate 3D commands are not useful or practical in this case. So I'm going to go with just the rotate command, okay? So type RO for rotate and select the second line from the top, enter. Now, I want you to know at this point, just that it occurred to me that probably you don't know about this. Rotations, when a three-dimensional rotation is concerned, you want to know the hinge, axis of hinge of the rotation. The hinge is assumed to be on the z-axis. And I know by heart, the z-axis is this line. So I'm not concerned too much about it because it's right now, it's asking me on the command prompt, rotate specify base point. The base point happens to be end of the line, but I know it's also on Z. The hinge is going to be Z-axis, and I think we're doing right. Click. Now, computer is asking me rotation angle, 30 degrees, type 30, enter. Rotation is made, exactly the way I expected. Enter again, rotate comes back. Select the line towards the close to end of the rotation, center of the rotations. I did select the line, select objects, enter. Base point is end of the line. When you see green mark, click. And now it's asking you the reference, the rotation angle. Rotation angle is now, last time it was 30 degrees, this time 60 degrees. I'm entering a number, increments of 30. Okay, so 60, enter. All right, rotation is completed. Enter again, select the object, select the line that you want to rotate carefully. Do not rush. Okay, enter, specify base point, that's the end of the line. Make sure that accurately you pick the end of, click like that. Okay, and then it was 60 degrees before, 60 plus 30 is 90. 90, enter, 90. Okay, it's getting very good. Enter. And finally, last line. And not last line, the one before the last line. And pick the endpoint. It was 90 before, now it's going to be 120. Enter. And enter again. Select the last line on the floor. Enter. Pick the center point. Okay. And 120 becomes 150. 30 plus 120 is 150. Enter. So far, so good. We have accomplished the footprint or the path line of the blade. Okay. What do I need? 3D poly. According to the instructions I have written myself, I need 3D polyline. Okay, 3D poly, type 3D poly. Enter, and find the end of the lines like the way I'm doing right now. Okay. Whoops. The moment I picked up, everything disappeared. I wonder if I should do it from here. Okay, from the top view. All right. 3D poly. Enter. 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 Select. Click. 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 I think everything has been selected properly. I think everything is, all of them are selected. Enter again and save your work. This is an important point. Okay. So all of this is good, but we still have a single line that's useful to us. And how do we convert this line, the single line, to a surface? I didn't know until I studied this particular wind turbine project myself. And I find, how do I do wind turbine? How do I do wind turbine? And I find a way. There's a command called surf network. Network. Everybody knows network, right? This is going to be surf network command. So I type surf network. Enter. Ta-da! It says select the curves or surfaces edges in the first direction. In the first direction. This is one edge, and this is another edge. Okay, does everybody see this? Good. Enter key. Now it says select the curves or surface edges in the second direction. Okay, and this is, everybody, are you seeing? Okay, this is one edge, and finally this is the last edge. Okay, we did that. Enter key. Computer says we cannot create a surface like this. I'm pretty sure we did this right. Okay. All right. Save our work. Okay. All right. Surf network. Okay, surf network. Enter. So this time I'm choosing the top and bottom lines. Enter. And I'm choosing vertical line and the curve we just created. Enter. Ta-da! It worked. Hallelujah. That's the way it's supposed to be. And this is good news. Okay, I want you to see a little bit better than this one. I'm going to change the shade mode. Shade mode. Enter. So that you can see. A realistic view. This is a surface. So you're looking at the surface, and surface is created. Okay? But it's surface. It is not 3D printable. It is not, it doesn't have any thickness whatsoever. So it's not necessarily useful. It's just a tool. Okay? This is just a tool that we're going to create, and we have to do it, and we just did it. Okay. So the next question is, how do we make it add thickness to it? There's a thicken command. Thicken command will work nicely and beautifully. Thicken. Thicken. And if you can use the thicken command, this will work. Okay. So let's type it. Thicken. Enter. Select the surface to thicken. Click. Enter. So the command now is asking me specific thickness. I was almost sure it's going to be like around 1/8 of an inch, but I just want to make sure that I'm doing this right, correctly. According to my notes, is it 1/8 of an inch or 3/16 of an inch? Could be 3/16 of an inch. Mm-hmm. 1/8 of an inch will work for me, but also I just want to make sure that I have degrees. Okay, this is 3/16 of an inch, so 0.1875. Okay, so thickness is going to be 0.1875. Enter. Ta-da! Thickness is done. That's cool. What else do we need? We need more number. Maybe 12 copies. Okay. My note says that, okay, don't do 12 copies, okay? Well, 16 copies. I'm suggesting, let's make it 12 copies. So let's go to array command, okay? And the array command is a very useful command. You can type it if you like to. And I'm going to do that just array. Select the blade that I have chosen, enter. Okay, it's going to be polar array, so enter. And it's asking you a base point of axis of rotation. This is 0, 0. Enter. Okay. But it gives you a bunch of options. It did the copy. And I'm suggesting select items and type 12. Okay. And also take a look at it, how it looks. Okay. This is cool. This is cool. This looks good. I think we can live with this, right? And enter. Perfect. Well, nothing is perfect, but because, why am I saying that? What nothing is perfect? Because I want the blade touch into the ground, into the base here, a little bit. So that's what I want to do. I want to move this base up a little bit higher if possible, okay? So move the blade a little bit up, base of the blade a little bit up. Why? It's asking you how much displacement. So at 0, 0, 0.05. Okay. this again. Select this, enter, and the displacement, enter, and add 0, 0, 0.05. Okay. Why did I do that? Because all the blades has to be secured into the material. They at both ends. Okay. Vertically, they are secured at the center shaft, but right now, so save your work. Okay. Material is very important. What kind of material would you apply? Steel, metal, carbon fiber, it could be anything. So I'm suggesting you go to RMAT. Type RMAT. RMAT is short for rendering materials. It's easy. So select everything. Something interesting, clear blue. Drag the clear blue over here. Oh, this is good. This looks so good. But I'm suggesting union first. Everything needs to be union. Enter. All union type L and enter. So that everything becomes one. That is critical information. So you union, enter, all, enter, enter. Okay, for some reason it did not do it. And so if it doesn't work first time, what do? We quit, get out of the way, take a coffee break and come back later or never do it again? No, we're gonna try and try again. Okay, so union is very big important command. I'm gonna choose it from screen on the ribbon, solid union command, select. Okay, enter, enter. Okay, I think it did it. Yes, very good news. Okay, now what else do we need? Oh, material, RMAT, select RMAT, rendering materials. Clear blue looks good, and let's make it, okay. Oh, this is really cool, okay. And save it. It's going to be transparent, maybe polymer, some kind of a polymer material. Okay, and you can render this too. And this is done. Thank you very much for your time. And then if you have any problems, call me. Okay, and I will be next to you and working with you, trying to answer your problems. No guarantees. There are certain things sometimes work, sometimes don't work. We all know that. But this is engineering work, so it takes research to find out errors, mistakes, and everything. I'm going to render it now, and have a very good, excellent day.